A bar is subjected to a combination of a steady load of 60 kN and a fluctuating between -10 kN and 90 kN. The corrected endurance limit of the bar is SE is equal to 150 megapascal. Yield strength is 480, ultimate value is 600. The bar cross section is the square of side equal to A. The factor of safety is equal to 2. The value of A you have to find out. That is the area you have to find out. And since a square, if you know the area, under root of area will be same as equal to the side A. You have to use the modified Goodman criteria. The corrected endurance limit of the bar is given as 150. So we have endurance strength is same as equal to 150 megapascal. And since we are using the Goodman, we required SUT, and SUT value is equal to 600. So we have SUT is equal to 600 megapascal. We have given here a bar of side equal to A, that is a square section of side equal to A, and the load is subjected here from -10 kN to 90 kN is a fluctuating, and we have steady load is equal to 60 kN. So we have to overlap these two load and then we'll get the fluctuating load on the bar. So we'll show here the force versus the time diagram. We have two loads here. One is a steady load and one is a fluctuating load. A steady load is a positive value of 60 kN. So let's mark here the positive load is equal to 60 kN. We have fluctuating load is from -10 to 90. So we have -10 and then it goes to +90. So minimum value is -10 and the maximum value is +90. These two diagram will overlap and we'll get the final load acting on the rod, which one is a fluctuating load. So at this point we have 0 plus 60, so we'll start with 60 here. This one is the resultant load. Then we have -10 plus 60 will be equal to +50. So we'll down to 50. This one is minimum load. Then again we come to 60 when the fluctuating load is 0. Then the fluctuating load goes to 90 plus 60. So it will shoot up to 150. And then again come to the mean value. So this value will be equals to 150 kilonewton. So this value represents here the peak value. And peak value is 60 plus 90, that equal to 150 kilonewton. So this one is representing the maximum load and plus 50 is representing the minimum load. This time we have cross section is a square cross section. So corresponding to this we develop two stress, one is max and one is minimum. So the maximum stress developed will be sigma max is given as the maximum force F max divided by area A, and the maximum force is equal to 150 kilonewton. So this value is same as 150 into 10 to the power 3 divided by the area A. Similarly, we can calculate the minimum stress will be equal to the minimum force divided by the area A, and this time we have minimum force is equal to 50 kilonewton. So we have 50 into 10 to the power 3 divided by the area A. But we require the value of sigma m and sigma amplitude. Sigma max plus sigma minimum divided by 2 is a mean stress. In this case we have max is 150, minimum is equal to 50. So we have 150 plus 50, 10 to the power 3 will take out common and is divided by 2. That is we have 200 by 2 is equal to 100. This is divided by area A. 100 into 10 to the power 3 divided by area A. Similarly, the amplitude stress is sigma max minus sigma minimum, which is equal to 150 minus 50. 10 to the power 3 is again common divided by 2 times of area A. 100 by 2 is equal to 50 is 50 into 10 to the power 3 divided by area A. Now we'll put this value back here in the modified Goodman line. Sigma m is equal to 100 into 10 to the power 3 divided by area. So 10 to the power 3 by area will take it common from both the terms. So we have 10 to the power 3 divided by area. Then sigma m is equal to 100 divided by SUT, which is equal to 600. So we have 100 divided by 600 plus amplitude value is 50 divided by A 10 to the power 3 early taken common divided by endurance strength, which is equal to 150 is equal to 1 divided by factor of safety that equal to 2. Solve this, you will get the area A. In this case, the area A is same as A into A, that is A square, because we have a square section. And we get the area is close to 1000 mm square. But we are interested in the side, so we have side value A is equal to under root of 1000, that will be close to 31.62 mm. A machine component is subjected to a stress which fluctuates between 350 to minus 150. Sigma max is equal to 350 and sigma minimum is equal to minus 150. Assume yield and the endurance as 0.6 and 0.5 times the ultimate strength respectively. The value of the ultimate strength you have to find out according to the Goodman line, taking the factor of safety as equal to 2.5. So we have given the value of sigma max is equal to 350 megapascal, and we have given the value of sigma minimum, which is equal to negative minus 150. And the endurance strength you have to take is equal to 0.5 times of SUT. In the modified Goodman line, we required SUT. SE, we don't require the yield strength. So we will not collect data for yield strength. We only require the value of SE. Factor of safety is also given. The factor of safety you have to take N is equal to 2.5. So using the sigma max and sigma minimum, first we calculate here the mean stress and amplitude stress. The mean stress is maximum stress plus minimum stress, that equal to 350 plus, and minimum stress is minus 150 is divided by 2. That is, we have 150 divided by 2 is equal to 75 megapascal, and the amplitude stress is sigma maximum minus sigma minimum by 2 is equal to 350. Minus minus become plus, will be 150 divided by 2. That is, we have 500 divided by 2 is equal to 250 megapascal. In the modified Goodman line, we know the value of sigma mean, that is 75, sigma amplitude equal to 250. SUT you have to calculate. Endurance strength is given in the form of SUT and the factor of safety is 2.5. So only one unknown is left that can be solved comfortably. We have sigma mean is equal to 75 divided by SUT plus sigma amplitude equal to 250 and the endurance strength is 0.5 times of SUT is equal to 1 upon factor of safety. Factor of safety you have to select is equal to 2.5. So this SUT can be solved comfortably, and you will get the value of ultimate strength is equal to 1500 megapascal. For a member under fatigue loading, the minimum and the maximum stress developed at a critical point is 100 megapascal and 250 megapascal, both are positive. The endurance, yield and ultimate strength of material are 300, 500, 700. Factor of safety using the Gerber criteria you have to find out. According to the Gerber parabola, we have governing equation is factor of safety multiplied by amplitude stress divided by endurance strength plus factor of safety multiplied by mean stress divided by ultimate stress whole square equal to 1. So we can find out here a quadratic equation for factor of safety and we'll solve it. But before this, we'll collect the data and we'll find out the amplitude stress and the mean stress. The minimum stress is given as 100 megapascal and the maximum stress is given as 250 megapascal. We require the value of endurance strength in the Gerber parabola, that will be equal to 300 megapascal. And we require the value of SUT, that equal to 700. So we have SUT is equal to 700 megapascal. So using sigma mean and sigma max, we'll calculate amplitude and the mean stress. So we have mean stress equal to sigma maximum, that equal to 250 sigma minimum is equal to 100 divided by 2. Total is 350 divided by 2 is equal to 175 megapascal. Sigma amplitude is sigma maximum, that equal to 250 minus sigma minimum is equal to 100 divided by 2. 150 divided by 2 is 75 megapascal. We have factor of safety is n, amplitude stress is 75, so we have 75 times factor of safety divided by endurance strength, which is equal to 300, plus sigma mean square, so we have 175 square into n square divided by SUT square, which one is 700 square, is equal to 1. So we'll develop here a quadratic equation. By dividing 300 and 700 square, you will get the constant is equal to 0.0625 times n square plus 0.25 times n is equal to 1. Now your quadratic equation here, so you have to select the positive root and you will get the factor of safety is equal to 2.47. A mechanical part made of a steel having endurance value is equal to 200 is subjected to bending stress alternating between 0 megapascal to 200 megapascal. The design is to be done on the basis of Gerber theory. The ultimate strength of the material taking a factor of safety as equal to 1, you have to find out. So we have a Gerber parabola is given as n into sigma amplitude by SE plus n into sigma m by SUT whole square equal to 1. You have to use the value of n is equal to 1 and you have to find out the value of SUT. We have given the value of endurance strength SE is equal to 200 megapascal. The minimum value of the stress is equal to 0 pascal and the maximum stress is given as 200 megapascal. So we can calculate here the mean stress as sigma max plus sigma minimum by 2, 200 plus 0, that is 200 by 2 is equal to 100, and the amplitude stress also equal to 100, that is 200 by 2. Factor of safety you have to use as a 1, so 1 multiplied by sigma amplitude is same as equal to 100 divided by endurance strength, that equal to 200, plus we have sigma mean is equal to 100 divided by SUT, and you have to make a whole square. Factor of safety is 1. On the right hand side we will get equal to 1. Solve this, you will get the value of SUT. This value of SUT come out to be 141.4. Now this is practically not possible because this value is less than the value of SE. So this is practically not possible. A brittle component is subjected to dynamic stress varying from 150 and 250 megapascal. Ultimate value is 450, SYT is 350, SC value is equal to 250. Determine the factor of safety using the modified Goodman criteria. So you have to solve the problem by using the modified Goodman criteria. In the modified Goodman criteria, you require the value of SUT and the value of SE. Out of that, we have given the value of SUT is equal to 450. So we have SUT is equal to 450 and we have endurance strength SE is equal to 250. The stress is varying from 150 to 250. So we have sigma minimum is equal to 150 megapascal and the sigma maximum will be equal to 250 megapascal. So first we calculate here the mean stress, which is equal to sigma maximum, which is equal to 250 plus minimum is equal to 150. So we have total 400 divided by 2, that equal to 200 megapascal. Sigma amplitude is sigma maximum, which is equal to 250 minus sigma minimum is 150. So 250 minus 150 is 100 divided by 2, that equal to 50 megapascal. So let's substitute here the mean stress, that equal to 200. SUT value is given to us is equal to 450 plus we have amplitude stress equal to 50 and the endurance strength is equal to 250. On the right hand side we have 1 upon factor of safety n. Solve it, you will get a factor of safety n is close to 1.5. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.